Good evening, everyone, and welcome to today's session of Saturday Talk by JanyuTechnologies. We are privileged to once again have Sri Sajal Ghosh sir for today's topic on Saturday Talk. A brief introduction of Sajal ji. Sajal ji, a former Vice President R&D and Technology at Tata Outcome Systems Limited, Composites division. Today he is going to speak on the composites, which is a part 2 continuation topic on the first lecture delivered by him before in this Saturday Talk series. Thank you, sir. Over to you from here.
Yeah, thanks everybody for joining the session. And as such, I deliver a talk on the subject, I think few months back. I've forgotten the date. And there I just gave a brief introduction of composite, mainly what is composites, major components of composites, and what are the, individual characteristics of each and major raw materials of composite play role in forming a composite material, whether that is be usable or not. That is basically we have made something, but whether composite is formed or not formed, there are various ways of checking that thing. So we have discussed all those in details, particularly for the resins, glass fiber and fillers, because these three are the major components in a composite product. Fibers may be of different kinds, resin may be of different kinds, fillers may be functional and non-functionals, and other way. But the basic intent of composites, the fundamental requirements remain the same, whatever the raw materials may be. But if we are defining it as a composite, so it needs to pass through certain parameters, and we need to check all those things before ascertaining that we have been able to get a right kind of composite material. And this material, when we use in practical application, there are different kind of loads, and for meeting those load requirements, when we are developing a composite material, we need to see and ensure that the requirement from the individual raw material components are performing individual job. And if you see the first slide on the graph, tensile stress and strain, from here we get a lot of information. Fiber, individual fiber stress strain curve, resin stress strain curve, and composite, the stress strain curve. FRP is a generic name, fiber reinforced composite, polymeric composite mainly when we are talking here. So fiber may be of any kind, and manufacturing process may be of any kind, or the resin may be of any kind. The generic name is composites. So strain, if you just see the strain axis, and from here we can define the strain percentage of resin, because that will be the first thing, the resin failure, crack. So when it is happening, so we can design that way. It said that is why we call composites are tailor-made, engineered. So materials are engineered and tailor-made for meeting a specific end-use purpose. Now this sheet molding compound. I thought to include a video for this one, for clarity of the audience. But I thought if I again put a video, it may take time. But I will see whether at the end, if I get some time, whether I can put a short video on this. Okay. So SMC technology. So here 1, 2, you are saying 3, all those things, mixing area means, So this SMC is really really a formulated and engineered product. Formulated, engineered, tailor-made. These are the three adjectives we can use for this. This material, it may be low shrink material, medium shrink material, zero shrink material, class A material, fire retardant material, conductive material. So you name it and you can do it. There is infinite opportunities to formulate it based on the requirement of the end use application. We know that composite polymer and composite by nature, they are the insulative material having the surface resistivity greater than 10,000 12 range and volume resistivity 10 to the power 14 range, like that. Okay, but and it can be also made conductive. We have certain application I have included at the later slide. So whether it is static dissipation or it is EMI, RFI sealing or beyond, and we have lot of application in electronics area, electronics packaging, and for EV battery management, all those things. We shall discuss all those later. And it's having, so SMC formulation is having many components into it, but the major components remain the resin, glass fiber, as well as filler. We add something to reduce the viscosity. We add something to inhibit the early gelling. We add something to get cure hardening during molding. We add something for getting release. We add something for getting thickening for handling characteristics of the material. So there are so many things. We can add FR material for getting the fire retardancy. We can add specialty material for getting a special type of requirement, including the conductivity, all those things. So that is why, being the formulated material, there are enormous opportunity to design it, to tailor it as per the end use requirement. So initially we make a slurry, liquid slurry, viscosity maybe 3000 centipoise to 50,000 centipoise. So that is will be in the slurry form after the mixing. And when we are mixing, so if it is in that form, if it does not mature, means the viscosity does not increase, so we cannot do anything with that material. So what we do, we add chemical thickener, and after adding chemical thickener, we are seeing that SMC line. So two arrows is there, two doctor boxes are there. It is similar to cloth coating. So we are getting the slurry in both the doctor boxes. From the lower doctor box, roller, there is a film. This film will be different type based on the requirement. So film, and it is getting coated. It is getting coated from the doctor boxes. And then we are finding glass fiber are getting chopped, that blue color, and falling on the bed. And then it is going forward. Then the another film getting coated from the upper doctor box. Then the glass fiber, chopped glass fiber, this chopping maybe 12.7 mm, maybe 25 mm, maybe 37.5 mm, maybe 50 mm. So depending on the product requirement, okay, both during manufacturing and both during end use application. So we are finding that the glass fiber is getting sandwiched between the two coated film, passing through the deaeration zone from where the air will get dispelled, and then going to the compaction zone, this roller you are finding, then we can either roll it and or you can collect it in a zigzag pattern that you are finding here. Then after manufacturing this thing, we keep it in control condition and at 30 degrees centigrade temperature for minimum 24 hours up to 72 hours, depending on the maturation level we expect, at least maturation level which we measure by the viscosity increase. That is basically the material, how it is getting thickening with the help of the chemical thickener. That viscosity minimum 10 million on CPs and above. So this general purpose, I would like to go to the specialty type. So innovation, what are the innovations happen in this area over the last you can say 1 decade. Okay, so this this happen. This slide is basically Tata Autocom system composite division. So these are the product you will find that generation 1 lightweight was 1.4 to 1.5 specific gravity. Then generation 2 1.2 to 1.4 this specific gravity. Now there is generation 3 also, whereby it is below 1.2. And in generation 1, we are using a waste product that is basically a byproduct of the fly ash. It is extracted from fly ash. Fly ash itself is a byproduct. So power industries, steel industries, all those things, they produce a lot of fly ash. So from there is a product called Cenosphere. So we have been able to use that product and totally eliminated a most expensive material, that's a nanomaterial, functional nanomaterial. But there is a difference. When we use the functional nanomaterial, we get very good impact. By using this industrial waste product, we have been achieved to get the lightweight and maybe able to meet the other performance, but impact has got impacted. Okay, but for the areas where it is not so important and it has been commercialized, and there are 3 patents filed, all the 3 patents have been granted, and these are being used practically. And then class A type, class A finish, SMC. So I can say the diversity in SMC function, the diverse function we can incorporate in the formulation, that is the major strength of SMC. Major strength. I can make a general purpose product, I can make a low shrink product, I can make a zero shrink product, I can make a structural product, I can make a showpiece product. Okay, so we can make a conductive product. SMC, if we put fire, it will burn like candle, but we can make SMC with not only B05V rating and fully compliant with the FST compliant EN 45545. That is particularly the metros, Alstom companies like Alstom specification. Okay, so this is a class A product. So this actually exported, it is basically a Packard truck. So Tata, they export quite good number of parts every month to them. And this material generally we don't get indigenously, generally import the raw material. But the good thing is that this, when we have made this material, our local content is very high, very, very high. Even for that FST compliant material, the local content maybe 98%. And I will tell you how the business came and what was the cost of export of this material and what we have been able to do here. Now this is the part. FST compliant SMC for metros and railways. So these are the requirement. And requirement, we have product with two different type of thicknesses. And this product has been tested in a by third party in a different country, not in India. And if you see the specification and the requirement and the performance of the product made in-house is exceeding the requirement sometimes it is a 10 times better, sometimes more than 10 times better. Okay, and this product actually I will tell you.
Who is making this? Sajal, who is making this?
This CD is making, sir.
Who is making the sheet? Yeah, who is making this sheet?
CD. Tata Autocom Composite, yes, sir.
Okay. And
we call it CD, Composite.
And this is anti.
Sir, I will tell you.
So these are very large components. How are they being molded? So very large components.
Sir, 3,000 ton press is there, na?
Okay. So largest piece is what size?
3 meters square area.
Okay.
So, sir, this John Deere roof, 3 meters square area, both inner and outer. Inner is structural, outer is semi-structural. Okay. Yeah. So there is a 3,000. I think, sir, when you were there, they got this press. Probably you did not visit. Yeah.
I remember.
Yeah.
No, I've seen this.
You have seen this, sir. And it is also parallelism control. It control the part, planarity at 20 to 24 micron level. And the requirement from the...
And what is the temperature? What is the temperature it can withstand? Alstom as well as the box.
Yes, sir. This temperature requirement is normal temperature requirement. But it can withstand the temperature of 120, 125, absolutely no issue. We have made it. But we got the order from Alstom because it's going to Mumbai metros, Delhi metros, Montreal, Prague, and there are in 4, 5. It's getting exported actually. Okay, quite few places. They actually awarded the business to CD with the assurance that we shall make this SMC in house. We used to import this material. I think landed cost used to be nearly €7 per kg. Now this is the thing. So we have unsaturated polyester. So still now what I was discussing, that is styrene base or less styrene base or without styrene but with high cost. So those systems we are working. But when you require the performance, this system, particularly the epoxy-based SMC technology, has become very popular in European countries, and I understand in China also for this epoxy-based SMC. So when we manufacture SMC, why unsaturated polyester is so popular for SMC application? Because in SMC, if the material does not thicken, then it will be a liquid. So you cannot get it as a sheet. And if you cannot make in that way, then to incorporate the so many functionality is also become very, very difficult. Particularly epoxy, fatigue strength is very, very good. Okay. So we have developed a product, definitely in collaboration with the epoxy manufacturer, but after certain point, this happen almost at CD only, because after certain point they cannot really help. So this material, epoxy cycle time, what is the cycle time? Is very high. In unsaturated polyester based, vinyl ester based SMC, cycle time for a product of I can say that this 3 meter square area product of 20 kilo product, your cycle time is maybe 7 minutes. But in epoxy, it's in terms of hours, all those things, few hours. There is some development in RTM area where they call that first cure epoxy in the range of, they call it just a single minute exchange of dye, but it's not single minute. Similar to they call is 1 minute cure time type of grade they have developed. So number one, to get the material thickened. So thickening technology is easy for our unsaturated polyester, vinyl ester resin because there is a acid group, COOH group, carboxyl group. So when we thicken, thickener is generally magnesium hydroxide base or sometime polyurethane or sometime other hydroxide, all those things, or mix all those things. So there is a acid base reaction and we get it. But there is no scope for this type of reaction in epoxy. Epoxy does not have those type of functionality. So challenging, highly challenging. So we are working there before I retire from the company. So you work 3 years. Last, I think in October last year, a full patent file for this and met almost all the requirement. Means in the same system and process, same machineries, equipments can be used. Shelf life also enhanced and cycle time they have come below 10 minutes. But for a big product, high performing product, both in automotive and electrical application, this is a very, very good development, and we can use it for structural application. That is the most important thing. Structural and semi-structural application, and it gets painted. So this is the technology. It's a totally no volatile content. Epoxy does not have any volatile content. So if you would like to eliminate any emission, workplace emission in composite industry, either we need to go to the thermoplastic or then epoxy or expensive material, but based on the unsaturated polyester resin. But there is a difference. There is a difference. The curing mechanism, the hardening mechanism for the SMC technology, that is basically a free radical type of technology, similar to fusion type of reaction, start and finish very fast. But this type of reaction basically, not free radical reaction. This takes place, from the functional group side of condensation type of reaction without producing any byproduct though. So taking care, so to make it the faster to make in the similar equipment, to mold in the same press, all those things. So there are a lot of technological challenges which have been overcome by the team, and I think now they are ready for mass production. But this is a very, very important technology happen indigenously. There are some development globally, but these are closely guarded information nobody share. There are some tier 1 supplier in Germany where they are using this material for battery pack in mass production. So these two photographs, actually I have recently visited China. So I visited a company and then found that this manhole cover is a manhole cover. Not only the cover, the entire structure is made of SMC. Definitely it is not the general purpose SMC. It's a very, very special type of SMC, but in different shape, different and size and different capacity. So the material is SMC and काफी high thick material. And this left side is a tank. It is also made of SMC material only. but it's a sewage purification tank. So chemical resistance, all those things are the requirement. And this right side manhole cover, it meets all the load requirements. Then 5G communication cabinet, similar to electrical meter boxes, switch gear, or all those things, similar to that requirement may be different. So this type of application is huge. Junction box, meter box, system assembly, all those things. And finally, this is this one actually this is for solar panel. Solar panel, this one, but this solar panel it is made of, the frame is made of composite. Okay, the frame is made of composite, and the interesting thing is that it's having anti-UV UV ability 3000 kilowatt hour up to that point, and carbon emission only 15% of aluminum frame. Aluminum as such is a very high energy consuming material when we fabricate the part. Then there is axial strength 5 times of the aluminum alloy. Salt spray level is nearly 8, and it gives very good potential induced damage resistance. And this material is green and recyclable. This material is composite, but not the type of composite what we have spoken so far. Okay, so that is the thing. So lot of things happening, not only in SMC, and BMC is another area for particularly for MCB, and switchgear industry. Those are mainly the injection molded part, and then an SMC, then and your filament winding is coming for your this cylinder, all those things, and your pull to sand is becoming very important process for so many products and assembly. So all those things are there. Then pre-preg is also there, compression, and pre-preg is also there for autoclave process, RTM, VRTM, and HPRTM. All those things are there. Infusion process are there for the wind turbine blades, all those things. But whatever the processes and maybe conversion processes, the basic requirements remaining the same when we say it's composites. This is the slide. I kept it on the last to consider if I get some time. So, but I think, and I was thinking to show some video, all those things. It is already 17 and 39. So what should I do? Bhushan, hello.
Hello, Sachin. Please, sir.
Yes, sir. Sir, the topic is so engrossing and you have such a deep knowledge. I think we can go on and on, but we have time limitation as we have external guest as well. So I propose, sir, just like this session 2, we can have the third session sometime as per mutual convenience, sir.
Okay, we shall see later. Okay, so what can be done? Okay, but right, one thing I would like to tell before I conclude, that composite, this SMC, BMC composite material, and this is a very versatile material for automotive, electrical, electronics, communication area, industrial and other application. It's having application almost in everywhere. So natural question come, it's being made of thermoset, is it recyclable? This because end of life vehicle, that's a very important criteria for all automotive designers. Okay, and they look for it. We have worked a good amount on this area, but I would like to inform the audience This product has got a green tag in Europe. I think also in USA. Okay, there are more than 4 million parts based on the recyclate of SMC, not only SMC, any composite product which are ground and then get up to certain particle, and those are used for a certain percentage in the fresh formulation. There are more than 4 million parts on European road which are having these recyclates. Plus, this can be used for co-processing of cement. Co-processing means it works both as a raw material, means is improve the quality of the cement. Okay, and also it also gives the require energy to bake it. Okay, require energy for the cement manufacturing. I was just coming to the bricks, that is why I use the word baked. So okay. So for during cement manufacturing, the energy requirement is also provided by this material regrind. So for cement co-processing is a very, very popular, and also for fresh formulation, all those things. Another things, this composite material, if you see the energy requirement for making 1 kg finished part from composite, the energy requirement is the least, even lesser than nylon material, nylon 66, nylon 6. Okay, so that way this material, actually the way we are telling to the customer, the way we are demonstrating, the way we are creating the awareness, it makes a lot of sense. It is not only selling composite product. In case of composite, it is the selling of the concept to commercialization. So selling concept becomes very, very important in case of composite business. Thank you very much. I'm sorry I've taken 13 minutes more, but if you have any queries, either you can ask me or you can send me my email and mobile number, which is also having the WhatsApp facility. You can send me. I will be happy to address your queries. I may not be able to have all the solutions, but whatever I will have, I will share with you. And if I don't have, I will try to know from others who know better than me. And if I get those type of things, additional and information, I shall be happy to share with you. Thank you very much. Have a great evening.